Hi, my name is IZZUDDIN. So for the presentation, we will start with the introduction. So mobile devices are essential for the students, but running out of battery in outdoor areas like the bus stops is a very common problem. So UM offers a very smart solution, which is the solar-powered power banks that can be rented and used anywhere on the campus. So the system is not just convenient, but it's also eco-friendly. In short, UM helps students stay connected, reduce stress, and embrace a greener future. The project begins in January 2025 with a kick-off meeting to align the team and finalize planning, including budgeting, deliverables, and risk strategies. By February, all planning components should be in place. From March to June, the team will focus on designing the hardware and kiosk structure while simultaneously developing the software and mobile app. Prototyping will be conducted by June to test the core functions. Then from July to August, we move into the procurement of equipment such as kiosks and power banks, while also launching an early marketing campaign to create awareness among students before the deployment. And from September to October, all hardware and software components will be integrated and tested to ensure smooth functionality between kiosks and the app. A full system trial will be carried out at the end of October. In November and December, the kiosks will be installed around campus and user training will be conducted. A soft launch and trial run will also take place in December, collecting feedback for improvements. The full official launch is scheduled for January 2026, followed by a post-launch monitoring phase. So this project spans over 6 phases, beginning with project initiation and planning in January, where we align the team, define deliverables, and assess the risk. In phase 2, we focus on hardware design and software development, ending with the prototype testing. And in phase 3, is about procurement of components and launching our early stage marketing campaign. And next, in phase 4, we integrate all system components and conduct full testing from September to October. And in phase 5, from November to December, includes the kiosk installation, user training, and running a feedback loop to refine the system. Finally, phase 6 with the official launch and the post-launch monitoring to ensure smooth operations.
Hi, my name is Muhammad AKRAM bin ZAHID, and for this part, I will talk about the budget for this project. For the budget, will come from the human source and the material source. The human source will estimate around 9.08 thousand, and for material cost, it will estimate around 88.8 thousand. And for the final financial source, we will estimate for this project it's require 1.175 million. For the cost benefit ratio analysis, the project will compare the solar and grid power kiosk, which over the 15 years using a 10 discrete compound rate. The solar power kiosk achieve a BCR of 1.17, meaning it's economically valuable for the long-term investment, while the BCR for the grid power kiosk will be 0.26, which is higher operational cost and lower annual benefit. For the incremental BCR, we get the negative 6.49, which is actually highlight that the solar kiosk deliver more value at the lower cost. So, solar power kiosk is more sustainable and efficient choice in terms of economy, environment, and operation.
Hi, my name is ASHRAF IZZUDDIN. So now I will explain a project planning process part. So at UM Charge, delivering an intelligent charging solution for campus means having a clear roadmap. That roadmap is built on a robust project planning process. So we begin with a work breakdown structure, or we call it WBS. This is essential to break down the entire UM Charge project into smaller, manageable components. The WBS captures and organizes every task from initial planning to full launch. Each task has a unique ID, duration, and specific start and finish dates. All enter into Microsoft Project for detailed tracking. This structure clearly defines task dependencies and ensuring we complete activities in the correct order, like prototype testing, happening only after system development. All this detailed planning culminates in our Gantt chart. This visual timeline begins on January 1st, 2025 and provides a clear overview of our entire project life cycle. From design and development to installation and operation setup, the Gantt chart visually represents each task duration and its position within the project, which is guiding us towards our targeted completion by January 31, 2026. Through our methodical project planning, including our WBS and Gantt chart, we are ensuring Charge is delivered efficiently and effectively, keeping our campus connected. Okay, for now I will explain the resource allocation method part. So at Charge, we are revolutionizing how you power up on campus. So we use priority-based allocation, which is ensuring those with urgent needs like students with disabilities get quick access when they need it most. So our system employs real-time control and demand predictions. It monitors usage and predict peak times, dynamically adjusting power bank and port availability to prevent congestion and ensure fair access. So if a kiosk is full, our centralized system reroutes you to the nearest available one through app notifications, which is saving you time and hassle. We use optimization algorithm to strategically place kiosks and power banks across campus, maximizing coverage and minimizing your wait. And with QR code and ID-based access, we ensure efficient turnaround, preventing extended usage and keeping resources available for everyone. So that's all from me. Thank you.
Charge brings more than just charging access. It helps normalize the use of clean energy by making solar power visible in everyday campus life. It improves digital connectivity by ensuring students, regardless of background, can stay connected in emergencies like blackouts or natural disasters. The solar-powered system can still provide support. It also reflects Mr. Maya's drive for innovation and leadership in smart green technology. The kiosks offer a real practical benefit to students, staff and visitors, and because they run on solar energy, they help reduce long-term electricity costs for the university. In conclusion, Charge introduced solar-powered GPS-enabled power bank kiosks to University Malaya as a step towards sustainable infrastructure and digital inclusion. These eco-friendly stations reduce reliance on electricity, support the university's sustainability goals, and align with the UN SDGs. Beyond campus needs, they promote clean energy awareness, research, and innovation. The model is scalable to other institutions, helping drive smarter infrastructure across Malaysia.